This is the introductory lecture of group theory, but in order to understand the definition of groups, we should actually know what actually binary operation is. But in order to understand what binary operation is, we should know the definition of function. So in this class, we are going to start with definition of function first. Now, as we have already learned what exactly function is, we will not go in details. We already know what domain is and codomain is. So we'll see the definition of function in terms of that. You might have already seen that the notation of function is somewhat like this. F from x to y. This x is called as a domain and y is called as a codomain. So the definition of function says if every element in the domain has a unique image in the codomain, then and then it will be called as a function. Let us jump towards the example. I have taken a set X as ABCD, which is my domain. I have taken my set Y as 1, 2, 3, 4, which is my codomain, and we have to check whether all these are functions from X to Y. X is a domain, Y is a codomain. Remember, the key thing in the definition is every element in the domain should have an image, but that image should be unique. Means one element in the domain should have exactly one image. And remember, every element should have an image, and every element further should have only one image. In fact, exactly one image. And remember that image should be in the codomain also. Sometimes what happens is every element in the domain is having an image, but that does not lie in codomain. So for example, talking about F1, so here image of A is 2. So A has an image. Remember, in the domain we are having 4 elements, that is A, B, C, D, right? So all these 4 should have image. That image should be unique, and remember that image should be in the codomain as well. So here under F1, image of A is 2, image of B is 3, image of C is 4. Does every element in X has image? No. D doesn't have an image here, right? Thus, this is not an example of a function. So this is not a function. Moving towards the next example, here we are having F2. So A has image, which is 1. B has image, which is 4. C has image, which is 2. And D also has image, which is 5. So every element in the domain do have image. Image is unique as well because A has only one image, B has exactly one, similar C and D. So will it be a function? No, the problem lies here. As you can see, the image of D is 5, but that 5 does not lie in codomain, isn't it? So whatever image we have, that image should be in the codomain as well. So therefore, this is not a function. Moving towards the next example, A has image, which is 3, B has image, which is 4, C has image, which is 1. Now D should also have an image, right? But D doesn't have an image. So every element in the domain doesn't have an image here. So it is not a function. And there is one more thing. A has 3 image and A has 2 image. So A has in fact 2 images, that is 3 and 2. This is also not allowed. Every element in the domain should have an image, and that should be unique as well. Remember that. Moving towards the next one. So here A is having image, which is 2. B also has an image, which is 2. C also has an image, and D also has an image. So every element in the domain do have image. Further, that image is unique also, and whatever image we have, that also lies in codomain, right? Therefore, it is an example of a function. Moving towards the next one, A has image, B has image, C has image, D has image. So every element in the domain do have image. It is unique also because A has 1, B has 1, similarly C and D as well. But the issue here is that this image of C and D is 5 and 7 respectively, but that is not present in codomain. So this is also not an example of a function. Moving towards the next one, A has 4 as an image, B has 2, C has 1 and D has 3. So as you can see, every element has an image in the domain. It is unique also, and the images are also present in the codomain, right? So this is an example of a function. I hope the definition of a function is clear.